Most industries run through cycles of stagnation from incumbents that lead to disruption from newcomers. And in the semiconductor industry, this has happened more so than in any other major business area. With the Model 3, Tesla showed that owning an electric vehicle was actually more economical in the long run than running a traditional gas engine car. And while they are currently competing head-to-head with the incumbents, Tesla are quickly developing new technology that will put them ahead of the competition in the not-too-distant future. There's an opening for Tesla's disruption model to be mirrored in the computer business. In the late 1960s, Intel started out as a Tier 3 memory chip manufacturer, but by disrupting the magnetic tape incumbents, it soon became a market leader with its memory and chip business thriving in the 1980s and beyond. Today, in turn, Intel is facing pressure from newcomers who are looking to disrupt their stagnant microprocessor business, which has been stuck on an architecture from 5 years ago in their volume products. One such company looking to disrupt Intel's dominance is NUVIA, who incidentally is backed by the Capricorn Investment Group, the same fund that was one of the first investors in Tesla Motors, a well-funded company with a leadership team composed of industry legends and an ambitious plan to take microprocessor performance to another level should put additional pressure on Intel. But is NUVIA just another startup that will be eventually bought up by a larger player? Are they coming into the semiconductor industry with an exit strategy in mind? Or are we looking at the new Tesla of silicon? I had a chat with NUVIA's Vice President of Software, John Masters, to try and understand what NUVIA's goal is, how they can possibly challenge a Goliath like Intel, and how the silicon industry in general will change in the next decade. Before joining NUVIA, John Masters spent nearly 14 years at Red Hat as Chief ARM Architect. He is an author for O'Reilly with educational books on Linux programming and building embedded Linux systems, and he was one of the first industry figures to raise awareness to the Spectre and Meltdown vulnerabilities in early 2018. After joining NUVIA, John's extensive experience with ARM-based systems further cemented speculation that the new startup was going to be building ARM-based processors, and that's of course one of the topics we discussed. I came into this chat somewhat skeptical of NUVIA's prospects, and it turns out they are far more ambitious than I expected. John, thanks for your time first of all, and I guess the first thing I'll ask is, what is NUVIA and what are you guys looking to accomplish?
Yeah, it's a good question, and also, thanks for inviting me to be here today. NUVIA is a server startup focused on building high-performance server-class processors for the data center market. And what we're doing is really building what we would like to see as leadership-class computing in the years to come. So there's a strong focus on single-thread performance uplift versus what you see in market today. So, not like, 10% or 15 or 20% better than what you see out there, but just, a lot better performance on a single thread basis. And then also looking at all the other things that you need to build a leadership class product. So that is good scalability, that's good IOs, that's good total cost of ownership, energy efficiency. All of these different attributes go into a whole design. And it's really about achieving the balance of all of those. But I would say that, the key differentiator is that we're building what I like to describe as, doing it the boring way, right? Something that just works, something that comes into market and gives you the ability to run all of the existing ARM server software that's out there today, but do it with just a significant performance uplift.
Interesting. We'll get more into the performance aspect in a second. Can you describe your typical day at NUVIA, if there is such a thing as a typical day?
Yeah, I can. I can describe my typical day in the context of the before and the after times, right? So we're we're now, as we're filming this, we're dealing with the pandemic around the world, and I hope everyone listening is staying safe. And of course, that has changed the day-to-day operations for a lot of companies, including us as a startup. And I think in many ways, as a startup, you're somewhat in a better position because you have a relatively small number of people who may be more able to quickly adapt to being online. So that hasn't disrupted us, but it has changed how we do things. So before this, what was happening was I joined NUVIA in November of 2019, and I'm the vice president of software for the company. So what that means is basically I'm building a software organization from scratch. We're responsible for the whole stack in terms of from power on, all of the firmware, working with all of the software communities to go and enable all of the software that's going to run on top. And again, as I said earlier, kind of giving you that boring experience where you take existing software and it just works. There's a lot you have to do underneath to make that happen. So that's kind of the remit, and then the day-to-day activity. Well, I'm actually remote in Boston, Massachusetts. I live in Cambridge, in fact, just across the river. And prior to the pandemic, I was flying to California at least monthly. And in fact, I think it got to a point where it was every other week, just to be in our headquarters at the stage that we're at of our progression. And then what I've done in the weeks that we've been under this kind of national lockdown and international lockdown is I've been working from home. Unfortunately, I did have a home office set up before all this, so it's been a little bit easier for me in some ways to adapt.
So how many people do you guys have at the moment? And if you can go into specifics, how many of those people are in the CPU design team?
So I don't know if I can break it down for you, but I can say that we're north of 120 people at this point. And when I joined, I was employee number 50 in the company. So I joined in November, and we are, more than double the size that the company was at when I joined. So we're growing very rapidly. One of the things I think that sets NUVIA apart from some of the others that have entered the market, and that's not a swipe, by the way, at anybody else, because I like everyone. I really want everyone to bring their A game and bring disruption and all these good things. But one of the things I think that sets NUVIA apart is that we are trying to do it in a way more smartly. So we're trying to have a nimble team that's in the hundreds of people, not the thousands of people sort of size. And there are many reasons for that. And one of them is just that, once you get a team beyond a certain size, a few hundred people, it becomes very difficult. You no longer really know who anyone is. I mean, I think the research says after you're about 100, 120 people, maybe the point we're at, you start to not really know who everyone is anyway. But there's clearly a point in time where things grow. You get more and more levels of middle management and all of these sorts of things. And we're trying to avoid that. We're trying to really focus on having a nimble team that's just the right size to do what we want to do, but has sort of no overhead beyond that.
So is that what compelled you to leave Red Hat and join NUVIA? I keep wanting to say NUVIA. I imagine people often think you work with skincare products.
Oh, I'll tell you a funny story. Okay, so I started talking to NUVIA in early to mid 2019, right? And I was chatting with the guys for months and months. Like over the years, I don't want to sound too arrogant when I say this, but a lot of companies have come to me and said, why don't you come join our band of interesting people doing something different? And I always said no, because I loved Red Hat, and I still do. I think they're a great company. And, I didn't leave because IBM bought them, even though the timing, certainly is suspect. I actually think that, IBM's got a great future ahead for it as well. Particularly if they listen to Red Hat. Take that as a hint, guys. But what happened for me was I got to a point where these guys came and said, hey, we're doing something really interesting. I'm like, okay, I've heard that before. And we had many conversations. And I think, I used to sit down with Gerard Williams, who's now my boss, and he would walk through some of his thoughts and ideas. And just the guy thinks in such a very different way. And he's the kind of CEO who, it'll be the early hours on the weekend and he's coming up with very interesting and novel ideas of ways to solve problems. He's just very, very hands-on, very, very engineering driven. Just a very, very, very smart individual. And he and a couple of the other co-founders there, in the end just wore me down. I thought, okay, look, this has a chance to be one of those great companies that everyone talks about. I would be a complete idiot not to embrace the opportunity. And the reason I was chuckling just now when you said about skincare products is that my fiance used to refer to NUVIA as the lotion company. That was our code name. And at one point she took to buying me containers of NUVIA just as a troll to say, come on, are you going to do it? Or, what are you going to do? Come on, you want to. And she had actually had been at a startup herself. So she works in technology as well. She'd been at a startup and actually ultimately got acquired by Google. So she'd had this whole sort of Silicon Valley dream experience. And, she told me, look, startups are not every piece of a startup is going to be great because it's a bit of scurrying around trying to figure things out, but it's a fabulous experience and you got a chance to be on the ground floor and build something, and you'll kick yourself if you don't. So yeah, and she was right.
You touched on something there that I thought about when NUVIA got out of stealth mode and revealed itself to the world. And I looked at the people who were on the leadership team, and my thought was, these guys don't strike me as the sort of people who are just doing this with an exit strategy in mind of just getting bought by Microsoft or Intel or someone like that. This looks like a group of people who have long-term ambitions. So I'm guessing that when you joined, you were well aware of that, and that was perhaps one of the reasons you joined, and not just to get rich with a buyout or something like that.
Yeah, I actually joked with the guys after, of course I try to be a shrewd negotiator. But, after I'd agreed to join, I said, by the way, I don't do it for the money. I've never done anything I do for money. I think that's a very privileged statement, isn't it? I'm not driving around in a Maserati. I drive a little Mazda Miata, right? So, I have a car I quite like, but it's not like the most expensive vehicle by any means. But I'm doing all right. And in the technology industry, unless you're, unless I decide to go and put on a chicken suit and run around, probably someone will employ me. So I kind of figured, you know what, you can always go and do it for the money later in life if you need to. Fortunately, I'm just at the stage where I'm getting married. Well, hopefully this year. We'll see with the pandemic what happens with our ceremony. But we're getting married, but we don't have any kids or dependencies or anything like that. And so, why not take a chance and try something? So I'm not in it to get rich. That would be great. I'd love to do that. And I'll invite you to the boat if I get one. But
I'll hold you to that.
But it's mostly about a chance to do something it's definitely a long-term endeavor, right? It's not about just let's all get rich. It's about saying the industry is ripe for disruption. So let's go and do that.
You were introducing NUVIA earlier. You talked about delivering industry-leading performance, but you also talked about energy efficiency. That's not an easy thing to accomplish. You usually either sacrifice on the efficiency side or on the performance side. And you're building a processor with the ARM ISA. And when we think of ARM, we think of very efficient chips, but not necessarily high-performance chips. So what do you mean when you say performance leadership?
So we don't cite specific numbers yet, but I think the terms we're using are step function improvement, and so from an IPC point of view, from a single thread performance point of view, like what we're trying to do is say you're going to get something very, very meaningful, right? When you get one of these parts, it's not going to be, just a small percentage increase. It's going to be such a high increase in performance that you're going to, even if you're not necessarily thinking about using an ARM server today, you're going to say, wow, that is worth me trying my workload on that particular design because that thing is amazing, right? So I can't speak to the specifics of the energy efficiency, but I will say it will be the highest performing, most efficient design that you're going to see for quite some time. When I first talked to Gerard about joining NUVIA, the thing was that he has ideas and philosophies for how he approaches design that are just so different from what I've seen before, right? So it's not just like take any other core or SoC that you've seen and just kind of do more of the same. There's just a very different design, and as a result of the approach to design that he takes, I truly believe, and I have seen the numbers, I truly believe that you're going to see something that is very different.
Yeah, I understand you can't go into specifics. There's, of course, a lot of specific details I'd love to know. One thing I don't quite understand is who are you going to target with your product? Because when we look at, for instance, the guys at Ampere just showed off their Ultra chip, and they have very impressive specs with very easy to market numbers like a lot of cores and good efficiency numbers also. I think they're going for around 200 watts for an 80 core parts. You talked about a focus on single threaded performance, but it seems a bit risky to go into a market where Intel is so entrenched and where software is so optimized to run on their chips. So who exactly are you guys targeting?
Well, I think I'm going to give you an answer because I'm trying not to become a politician. but I think firstly there's a very big market and it's growing. There's insatiable desire for cloud computing growth. So clearly we're going to be looking at the cloud space, the hyperscaler space. I mean that's an obvious market to go after because you have a relatively small number of players that buy many chips, and so if you get a couple of design wins there, then that can more than fund the company and keep it quite happily in business. But the market overall, if you look at it, there's a couple of things. So people know that personally I'm not a huge fan of Intel, but just excluding that personal opinion for a second, I think. What a lot of the other players are doing is they are trying to build something that is a single design that's trying to address a lot of different segments, and they're making trade-offs as a result. So, I have a laptop here. It happens to have an x86 processor in it today, and that same design is something that's going into whole different families of parts. So you have to make certain compromises to pull that off. Versus if you design something that is targeted to server space, targeted to very high performance IPC, and so on. How that differs from say the other ARM vendors? Well, firstly, I wish Ampere, Marvell, and HiSilicon, and all the others. I wish them well. I describe them as members of the pirates in the harbor, right? So we all know who the Royal Navy is, and sometimes if you're a pirate, you don't necessarily want to be going after the other pirates because they're not really the ones that you're necessarily competing with. But but I do think that ARM as a company, they have a great architecture, they have some great IP, but again, they make design trade-offs when they build their IP. They are targeting certain levels of performance. They're targeting designs that scale into all kinds of different markets. They've come at this from the perspective of portables and mobile, and scaling that up. The design that we're looking at is tailored for a different space. We've all seen the Moore's Law discussions. We've all seen your videos and other people's videos on some of the challenges that are happening. I think there's actually a lot of benefit there. When you look at the fact now that pretty much everybody has equal access to, if you've got big enough checkbook, equal access to leading edge manufacturing. What it means is you can no longer sort of compete by, just having the best manufacturing, right? Everyone can have the best manufacturing. Now what you have to do is you have to apply really good architecture concepts to build a much better design.
You mentioned hyperscalers as one of your target markets, and I had a quote prepared here, which I'm going to read to you, and it's from a respected engineer, and perhaps you'll have some comments on it. So I quote, "The interesting thing for me about Amazon's Graviton is that it's based on a processor that they themselves built, and this is really the culmination of what we're seeing in the industry in the past few years. As the cloud vendors get bigger and have greater resources, they can say, we would like to deliver this to our customers and we don't have to wait for someone to build it for us. We can just go and build it ourselves." Do you know who said this?
Was that James? Who said that?
No, it was you.
Oh, oh yeah, it wasn't okay. It could have been a Hamilton original as well. Yeah, interesting. Yeah, so I guess I did say that. Yeah.
So how do you reconcile what you said back in 2018 with what you guys are trying to do at NUVIA? I mean, if you're going after hyperscalers especially, there's the risk that what you described then happens now and they go out and build their own chips.
Well, so I like that question. That was nicely done. I'm thinking about that interview now. I know where you got that from. Yeah, good. So what I would say is it reconciles completely, and the reason it does is because look, take Neoverse as an example, ARM Neoverse IP, right? If you can't build something that performs better and offers other TCO advantages beyond taking Neoverse, which is a really good design, right? Like I think ARM did a really good job with Neoverse, right? But if you can't build something that's more interesting than just taking a bunch of M1 cores and putting them into an SoC, then why do it, right? Because that is now the entry bar, right? So it's actually good because if I was just sitting around waiting for Intel to come up with something interesting, I might be waiting a while. You're at a point where a cloud vendor is a company that potentially wants to work with all of the silicon suppliers out there, but also is competing with them, right? They can build their own. But I would say, though, that even there's a difference between licensing pieces and building a really, really good SoC. I mean, Graviton and Graviton 2 is a really, really nice design, right? So they did a really good job with that. But there's another level beyond building an SoC and then also having the ability to go and customize the cores themselves. So I think over time, if I were a cloud vendor, frankly, and this is my own personal opinion, I think the cloud vendors will want to do both, because I think what they will do is, look, if you're worth $1 trillion, right, you're now, almost an order of magnitude more money than a lot of the other big silicon companies out there, right? And what you want to do is you want to hedge your bets. You want to say, wow, I'm buying crazy numbers of chips from a small number of companies, and so I would imagine that all of them will probably have plans over time to build up expertise. But you see, even when cloud companies are building their own designs, it doesn't preclude them from still working with others, right? So I see this kind of happy coexistence where if what you're after is a kind of your Xeon Gold, right? If you're after like your mid-market offering, then the cloud vendors are going to be able to deliver that by going to merchant silicon vendors or by just building their own. But there's still going to be, I think, a very interesting opportunity for those who can offer something beyond that. And it's something beyond that that's really interesting me to do what I'm doing.
You have been a proponent of standards, and perhaps with something like NUVIA, which you mentioned, it supports CCIX, and perhaps we can see a future where one of these hyperscalers could make an accelerator and then pick a block from NUVIA and then add something of their own to it.
I would like to see it. In fact, just to add a little bit more there. So, in my previous life, I was very engaged in, C6 and CXL and Gen Z and OpenCAPI to an extent as well. I mean, I think I tried to collect them all. And I think it's a matter of public record now if you look at the some of these consortium websites that NUVIA is also a member of, at least one of them. There's definitely a future there where a lot of these whether it's merchant silicon or in-house hyperscaler designs, that having the ability to do high performance, cache coherent acceleration is going to be a tremendous benefit. I used to have this dream in my old life that I was pushing for years, because you have to sort of sell a dream, especially with hardware, for many, many years before it ever exists or a customer can really embrace it. I was pushing ARM servers, nearly 10 years ago, right? And it's a 10-year journey, but you have to kind of sell it in a way that people sort of, maybe they don't realize it's going to be 10 years. And with these accelerators, I used to push this idea that, you have your OpenStack, if you're Red Hat or IBM selling a cloud solution, or if you're a cloud vendor, you have your own in-house cloud. And what you want to be able to do is you want to be able to spin up a cloud instance. And at the same time, that instance image that you have, your disk image that spins up, it should come with a FPGA bit stream, if you want. And as you spin up the VM, it should also provision an FPGA that's coherently attached and instantiate whatever kind of accelerator you want. And if you do it right, you don't need to have all kinds of drivers because of the coherent properties and the memory semantics here. You can actually just have your driverless, seamless accelerators. So a cloud vendor has a tremendous advantage there, because they can give you that kind of boring experience where you spin up a VM. As you spin it up, an accelerator gets provisioned. Possibly it's an FPGA with your own bit stream that gets put in there to give you some kind of acceleration. It just happens magically, and then your VM is able to be doing both compute and also acceleration. So I think it's an interesting opportunity, and it's something that I hope we see built in the not too distant future.
Last year, Linus Torvalds had some interesting comments to make about ARM. So what needs to happen within the ARM ecosystem for it to overcome this barrier in developer adoption that Linus pointed to?
So firstly, that's a very good question. And as I often say, I don't want to become a politician, so I want to give honest answers. What happened? Let's take a trip down memory lane, right? So I have this collection of old computers in my office here. I have a PA RISC machine. I've got a bunch of DEC alphas, and I've got one of the boxes in the corner over there is an Itanium. I actually was a fan of Itanium from it's a very different kind of architecture, and I like funky different historical architectures. But when they brought that to market, the thing was they had a 32-bit x86 architecture, and they wanted to go 64-bit, and they wanted to do it from the most purest point of view possible, right? So they said, well, let's have a clean sheet, let's redesign everything, let's go and do this and this and this. Now they got killed in the market because AMD, Greg Faber and a couple others, Jim Keller, Greg, et cetera, basically said, okay, great, but let's just extend 32-bit x86 and add 64-bit to that. And of course, that won in the market because it was very easy to adopt. But Itanium had another issue, which was at the time they were trying to come to market, it still mattered, right? Binary software build still mattered a lot, right? You had a huge dependency on third-party commercial ISPs, and you needed them on board, and you needed, a lot. It was a lot different from where we are today. Today, when you look at these hyperscalers, right, and you look at developers that are developing for the kinds of emerging opportunities that we're looking at, these cloud native developers, they're not compiling binaries anymore, right? I mean, people are still writing, assembly code. They are still building binaries, but most of the sort of cloud developers out there, these cloud natives, they are using higher level languages which weren't as prevalent at the time that the Itanium came around, right? And they are using technologies that are just very different. So I've had this conversation with Linus, actually in person. I had this conversation with him before he made that public comment, and then also after, and I told him he's still wrong, right? And what I said to him is, look, from a Linux kernel developer's point of view, he is absolutely correct that he wants to have a laptop, or who wouldn't? I'd love to have a nice ARM-based laptop that's amazing. That'd be wonderful, right? And I hope that happens in the years ahead. But he's looking at it from his point of view as a kernel developer who's building kernels and building software in that sort of the sort of model that a lot of us still live in, right? I myself am not a cloud native. I have written a fully containerized microservice for our wedding website. It is checks every box because we wanted to go and do it ourselves.
Who doesn't?
And who doesn't, right? But I'm still in myself. I'm still a person who uses, I only just started using VS Code, right? I use Vim. I don't use a graphical calendar. I use Cal, as we were talking about on Twitter the other day, right? I'm living in the past. I'm trying to embrace the present and the future, but I live in the different world. I live in the world where, I build software here and I put it somewhere else and all this kind of thing. This next generation of developers, that's not where they live. They build containerized images, right? Now, it has all kinds of benefits, has all kinds of downsides from a security point of view. You pull some container, and who knows where that came from, right? There's all kinds of issues there. But the mindset is I just make a Docker file, for example, shove a few scripts in there, and off it goes. And so, you're already seeing multi-arch support, as they call it, in container registries. You're already seeing, Docker, as an example, have a commercial product. Actually, there's a free desktop version that does this too. But basically, you can build a container on your laptop, whatever flavor of laptop it is, and they will do a build for ARM. Basically, it's saying that the industry has changed so much in the last 20 years. It's almost unrecognizable from the point of view of the kinds of developers that are coming out today. There are still people that need to write hand-optimized, handcrafted assembly and need to understand memory barriers and write code in C++ and all this kind of stuff. But a lot of people don't. And a lot of people now, even people graduating with computer science degrees, don't have to know a lot about architecture. It's just changed so much.
One of the things that you brought up was that there are a few things that x86 doesn't do very well. Recently, one area where we saw this happen was regarding security, especially with Intel. If you have SMT in your designs, you're always going to have some vulnerabilities to side channel attacks. So firstly, why do you think Intel has been so affected by these vulnerabilities? And what are you guys planning to do to address security concerns? And secondly, ARM has been known for their advantage in efficiency compared to x86, but for instance, AMD's Rome is already offering a many-core chip at the 200-watt mark, and that's a very high-performance part. So what are your thoughts on those two chinks in the x86 armor that an ARM system can potentially exploit, the security vulnerabilities and x86 tradition with poor efficiency?
Well, let's deconstruct that. So on the security side, I think the thing for many years the industry prioritized performance above all else. Because any kind of comparison was always going to be about my performance is better than everyone else, right? My performance is better than this or whatever. Until January of 2018, if you were to make a comparison between two processors, security might be on your list, but it was very much an afterthought across the whole industry. So nobody was incentivized to prioritize security over performance. And only in the last few years has there been this reckoning where people have really started to ask themselves, what is more important? I would argue that the number one priority is security in this industry today, and it's far more important than in the past, because in the past you had, depending what generation we all grew up in, right? I'm a kid of the 80s, and so I remember getting a 286 and a 386 computer, and what happened with the PC class computers is the evolution continued, and the same kind of technology ended up in the public cloud, for example. But the threat model changed because you changed from having a single user on that machine to now taking the same kind of approach, but you have many shared users in the public cloud setting, or you have millions and millions of homogeneous units that can all be attacked as a nice single surface. The actual threat model has changed because now you are in a setting where some bug or some hardware vulnerability or design flaw can take down large numbers of machines at the same time. So I think the whole industry has learned from that over the last few years. It's not exclusive to Intel. They've been, somewhat the scapegoat, I think, for just the whole industry with this. I would say, though, that some other lessons have been learned, and they include that some of the little tricks that people took in design, saving a few gates here and there, Meltdown as an example, right? Well, Meltdown is really about just saving a few logic gates. Some of those sorts of design philosophies really needed to change earlier. They certainly will now. There's a recent attack that you might have seen there called LVI, load value injection, which continues the trend of exploiting what happens after some speculative code path should have been completely squashed or killed, right? So you do something, you're going to take an assist, you're going to have some microcode go and do something for you. So you say, okay, well, since I'm never going to care about the result, I'll just let this little speculation chain continue a bit longer because just let it die later. What you need to do these days when you're designing something is you need to think about, should I let that happen? The answer is, of course, no, right? Every time you're speculating or you're doing anything in your design, you need to make sure that you stop doing whatever it is at the earliest possible moment that you know you shouldn't be doing that, because someone will find some issue with it later. So there's a lot of sort of design philosophies that people have discovered there that need to change. To your second point about sort of x86 in general and the resurgence of different players and so on. Look, I mean, I've always been quite fond of AMD. I think they bring good competition in the x86 space, and I don't like to speak badly of the competition because I think we're all in this together. I think what we're trying to do is just give something that's, you know, much higher performing than the others in the market. But they certainly lifted the bar. They've raised the bar there in terms of, you know, the number of cores that people are expecting, the amount of performance that people are expecting. That is a good thing, right? You actually want to see that in the industry. You want to see forward progression. I think that x86 has a lot of challenges ahead in the next few years. There's a lot of the sort of original encumbrances of x86 are going away in the next few years, so it'll be something that I expect. You know, a lot of this is not a NUVIA comment. I expect to see a lot of people across the industry look at x86 as something that could be you know, implemented you know, more freely than in the past. But I also think that x86 has a lot of other reckonings coming for it. It's got a lot of baggage as an architecture. It still has a lot of the remnants of you know, real mode. This is before 32-bit, right? They still have a lot of you know, segmented memory, segmentation, and so on. Lots of instructions that are legacy that they end up supporting, and right, there's all kinds of tricks you could take that would mean that you could simplify even x86 designs, because they are very, very complicated. They're very, very hard for someone to understand. You know, I spent years of my life, in my old life, running security mitigation efforts and dealing with lots of different architectures, and I learned a lot more about x86 than I ever thought I would know, having sworn myself off it. And you know, it is a phenomenally complicated thing. I mean, it's, you know, yeah, it's variable width decode, but you know, you can have, you know, 15-byte instructions with all kinds of prefixes that do all kinds of crazy things. So it's a very complicated architecture, and I think if they were to look at simplifying that over time, that would probably benefit them.
We're definitely living in really interesting times, with some people in the industry calling it a new silicon renaissance. Last year we saw things like that wafer-sized Cerberus chip, and recently I covered the A64FX, which obviously is very domain-specific. It seems to me that it's hard to predict what the right approaches to chip design are, which can be a risky thing in an industry where you have to plan things 5 to 10 years ahead. So what sort of technologies do you see as being important to be implementing in your designs now that you think will prove to have been the right call, you know, 5 years from now?
Well, that's a really good question, and a really good statement of the industry as a whole, right? So just to pontificate a bit, because I like to pontificate, you know, I see this trend in the industry, as you pointed out, towards you know, the death of Moore's law is apparent. I know, you know, Jim Keller and others like to say it's not, but it's dying. It's certainly getting harder to just rely on manufacturing improvements. And so, to your point about Renaissance, right? So you know, John Hennessy gives this talk very often about the golden age and the new Renaissance era that we're entering of architecture, and how we now, you know, actually people start to care about architecture again and start to try innovating with new hardware designs. It all connects together, because what Hennessy is saying is, in his examples, is because we're not just getting faster and faster chips every year, people are having to look at the software that's running on top. And he goes through this example where he takes an application that's written in a high-level language, Python, a high-level language. and he goes through these different phases of optimizing it. By the time he's done, just changing the software, it's 50,000 times faster than when he started. So his line is always, look, if you're lucky with a chip, if you get tens of % faster a year. I mean, if you got a chip that was twice as fast as the previous year, that would be unheard of, but great, and the idea of having a chip that's 50,000 times faster than the previous generation is just ridiculous. And yet there has been this expectation all along that people would just get faster and faster computers, and that would be the solution. So I think there is a need, as we go into this new phase, to also look at the whole stack and think about where you can make optimizations. You're always going to have to deal with higher and higher level languages, because those are where people are entering the industry today. That's where we have the largest number of programmers. So you always need to have something that addresses more and more abstraction. But you also want to try to kill abstraction over time where you can. So it's one area where I'm actually in agreement with Raja Koduri has been pushing this one API concept at Intel. I'm not sure what I think of one API. I think that's a bit of a grandiose term. Good luck. But I think the general gist of it, that you have you have this idea of trying to work with hardware and software people together is a good idea, and I do think that we need to have more collaboration. We need to go and rethink how we have done things as we go and build the new world. The new world needs to be very flexible. The idea of building a chip in the next few years that has just one whiz-bang ML accelerator and it's the only way to do things, I think could get people into trouble if that isn't the right path. I'm a big believer in attaching accelerators to good old-fashioned boring compute, because I think compute is going to be there for a long time yet to come. So if you can give people really, really high-end compute with really good, really well-balanced design, really good access to memory, really good IOs, and let them attach all kinds of interesting accelerators and build interesting platforms, I think that is going to be a more winning approach as we go into the next few years, because there will be so much disruption. There'll be so many different ideas being explored that you really want to let the cloud vendors or system builders or anybody else that's putting together solutions. You really want to let them make as late or binding decision as possible. Because otherwise, again, you'll go down a path that's 5 years out, and unfortunately, you'll get, as you were alluding to, you'll get a year or two down that path, and you will potentially discover that you went down the wrong path. And misspeculating with hardware designs is a lot more expensive than just speculative computing. I guess that's the ultimate speculative computing, right?
So, moving on to the last couple of things I'd like to touch on. Last year we had a bit of a back and forth when I did a video on RISC-V, which has been gradually getting a lot of momentum. Mm-hmm. Obviously I didn't take that personally. I'm happy to have those sorts of discussions because I don't know everything, and it's important to get different perspectives. But you seemed skeptical at the time about the prospects of RISC-V taking over and do for hardware sort of what Linux did for software. So I wanted to ask two things. If you do still think that on a personal level, and secondly, if now being part of NUVIA forces you to have to consider RISC-V as an option for your products, because I'm guessing you're not married to ARM.
Those are very good observations and questions. So, I'll speak to my sort of perspective on RISC-V, which has always been very similar. In fact, as I'm speaking to you, I have a RISC-V board on the desk in front of me, and I have I've got two RISC-V boards on this desk and a RISC-V set of books on the shelf behind me. So maybe that says something. Look, I think RISC-V is a fabulous approach to democratizing computing, right? Firstly, I'll take the academic perspective and I'll take the commercial perspective. Academically, it's high time we had something out there that people could take and use and learn and just build real interesting machines with. You can now have students in school that can take an FPGA and build something very interesting that is an out-of-order design that does more than just a little in-order microcontroller, and they can build whole stacks and learn how it works and innovate and contribute, and that's great. There's just locally to me, Boston University has a project called Black Parrot, which is a Verilog-based RISC-V design that's not written in Chisel. Chisel being the generic abstract language that I'm not a big fan of. That Boom and other RISC-V cores are done in. But yeah, there's a lot of cool stuff happening there, and I really think from a academic and hobbyist point of view, if you want to learn about how computers work, you are now living in the golden age of being able to get access to the innards and learn more and more and more. It still doesn't quite solve all the pieces. I wanted to learn about manufacturing and building cutting edge processors, and you unfortunately still need to be in a commercial environment to do all of that. It's one of the reasons why I'm doing what I'm doing, to fill the gaps in my knowledge in. But you can learn a lot from RISC-V, so it's great. Commercially, I think RISC-V has a tremendous potential to really disrupt everybody, which is actually a good thing, because there should be, this is my own personal opinion, there should be no monopolies anywhere, right? Monopoly is not a word that I like, except maybe the board game. Maybe that's okay. I have the .com Monopoly edition. That's quite funny because most of those companies don't exist anymore. But look, monopolies are not a good thing. Competition is something that is very important to keep people honest. And in the same way that ARM is disrupting, x86, RISC-V will ultimately disrupt ARM, right? In a lot of different areas, particularly I think in microcontrollers first, because it's just a very easy space to get into, and then it'll probably disrupt mobile as well. And the reason it will go that way is because of the software story. If you are building a widget today, a fitness tracker or an IoT light bulb or something like this, if you're building an IoT widget, what are you going to do? Well, you're going to go and take Zephyr, which is an open source Linux Foundation project, actually, and you're going to go and put that on your light bulb, because you can do updates, and there's a couple of companies out there that try to be the Red Hat of Zephyr and RISC-V, and I think they have some good opportunity there to go and do that. So you'll have software that runs on these things, but the software there today is still in that sort of embedded infancy phase where it's very device specific, even if it is using a general purpose, RTOS like Zephyr. That'll help. That'll be okay in the IoT space, in the microcontroller space. Maybe we'll see something in the mobile space. Again, there's not many different mobile operating systems to choose from, and let's say take Android, right? Someone can port Android to RISC-V. They can run Android on a RISC-V processor. Android is effectively running jittered code anyway, so in the same way that Android runs on x86 and ARM, there's no reason you couldn't have a RISC-V phone and run Android on it. So that's something you could do. But to go further up the stack, you need standardization. And the reason I was interacting with your comments last year on RISC-V is that RISC-V has tremendous potential to climb that stack, to get into laptops, to get into servers, to get into general purpose computing. But it won't be solved, and it won't happen unless they heavily standardize the platform. I'm not going to speak to exactly what NUVIA might say there, but I except to say that actually we are taking a we're building something that's very flexible. We are today we are an ARM-based server design, but the design we have is very robust and is very flexible in our approach. And we were at the RISC-V summit. Who wasn't? and I plan to get more involved in the RISC-V space. Partly that's my own personal interest, which is in everything. But I think look, if RISC-V gets traction, I think it's something that we all want to be looking at in the years to come.
And my last question for you, for those watching or listening who might be interested in doing what you do, be it on the software side or the hardware side, what should they do? What should they study? What are your recommendations in that regard?
Yeah, it's a good question. I've been very fortunate in my career to date that I've taken an interest in lots of things, and I've been able to sort of finagle my way into working in areas that I want to. I would say, look, we talked about RISC-V earlier. If you're looking at computer architecture today, you can get easy access to just all of these pieces. I mean, if you want to understand how a computer works inside, firstly, there's so many great books. I mean, there's Computer Architecture from Patterson and Hennessy, and it's just a classic tomb on this topic. But I'm actually a very visual learner, so the way that I like to brush up on my knowledge or learn interesting new things is I watch lots of YouTube videos. Of course, I watch everything Cortex publishes and a couple other of the usual suspects too. But I love to watch lectures. I mean, you can be in university now or in high school. You could be in your career. I mean, be any different phase of life. But it doesn't really matter. What you can do is go on YouTube and you can watch amazing lectures. I love one lecturer in particular, Oner Mutlu. He's industry renowned professor who also went into the commercial space and then left because he wanted to go and teach. So that's great because he did it the right way around. He has all this experience and knowledge and he teaches his students. But he also puts all his lectures online, and they're just a fabulous way to learn about architecture. So, you can learn the academics of it, you can read the books, you can watch all these lectures online. If you want to dig into particular topics, I like things like cache coherency and memory consistency and all these areas, and there's all kinds of lectures on that online. And again, having been in the open source software space, look, you can, of course, you can have Linux on all kinds of computers. You can have Linux on an emulator, right, running software on your laptop, emulating some interesting computer that maybe hasn't existed for a long time or maybe doesn't exist yet, something that you're building. You can download QEMU, which is a popular open source emulator, and you could implement your own ISA and decode it and run software on there, again, using all these open source components. But you can also go and get involved in communities like RISC-V and download soft cores, put them in an FPGA at home for not a crazy amount of money, and you can run whole software stacks that are completely open on top of a hardware stack that's completely open, right? And then when you get bored beyond that, you can start going into silicon manufacturing and learning about how that works. I really enjoy Chris Mack. He's a now retired professor. He was at UT and did lots of stuff in industry before that. But he's got a great lecture series on silicon manufacturing if you want to go into it. So there's just so much out there, and none of it has to cost you a lot of money, and it doesn't necessarily mean that you have to be anywhere in the world or have access to particular people or anything like this. It just takes a little bit of your spare time if you have enough of that, and in some cases a little bit of money. But it's not very expensive to learn and start getting involved. And then I would say finally that just the great equalizer, right? The internet. If you have the ability to get on Twitter. If you're listening to this, probably you already are on things like Twitter and Discord and so on. You can connect with industry leaders, right? And I'm not counting myself here. I'm saying that there are other people out there that I really respect, that I follow on Twitter and I learn tremendous amounts from, and you can interact with them, right? CEOs of major silicon companies, you could tweet at them and they might respond to you, or at least you can have an interaction with them. So there's just so many ways that you can learn and get involved, and they needn't cost you a crazy amount of money, or they needn't necessarily mean that you have to travel the world or go to the best school or any of this kind of thing. It really is up to you to have this journey if you want to.
It sounds like NUVIA are planning to be more than just another startup that gets acquired by Intel or Google, but rather bring to market a flexible design that will be truly disruptive. I think it's particularly interesting that 3 NUVIA founders have all been instrumental at Apple and helped Apple go from using third-party IP for their products exclusively to nowadays designing the fastest mobile chips in-house. If you remember my video from last year on Apple moving to ARM for their MacBooks, you might remember how Apple's plan is to get rid of Intel and move to designing their laptop and desktop chips in-house. Think about it. If there's anyone who knows very well what Apple is planning, it's these 3 guys who helped design and build Apple's A-series chips. The fact that Apple is moving completely to ARM and we're seeing NUVIA show up with what John calls a very flexible design might not be a coincidence. Even though NUVIA's announcements so far have been strictly aimed at the hyperscaler and data center business, I suspect we might see NUVIA as a key player in the industry if ARM does take over outside of the mobile space. I'm certainly looking forward to that NUVIA many-core workstation to edit these hour-long videos on. A huge thanks to John for his time, and be sure you subscribe to my channel so you don't miss my upcoming videos on other industry disruptions that are emerging. This video was made possible by my awesome patrons. Join my Patreon today for just $1 per month and help my channel continue to exist. You can also support me by buying a mug or a t-shirt, links below. Thanks for watching, and until the next one.